All right, so start talking about scope. Um, so one of the reasons why yesterday we were belaboring one of the reasons why we were belaboring the point of having your code properly indented is because those curly braces are actually very important, right? The spacing was not necessarily important, but the curly braces themselves are very important because curly braces in JavaScript set something called scope. You can think of scope as almost like a sandbox or a playground, or and put it another way, it's the boundaries of your code. And so, if you can imagine where the boundaries are obviously extremely critical for having your code run in the way that you expect it to. So the three types of blocks, or sorry, the three types of scope we'll talk about today are global, functional, and block. And then just we'll cover some obviously basics about their use cases. So one of the things that you'll realize in JavaScript is that not everything on the page has access to everything else on the page. So far, we've written very, very simple things where it's, we define a few variables, we have a function, we run that one function, it calls the variables, and we kind of, on the surface, it looks like, hey, in JavaScript, we just write anything anywhere on the page, and we can use it anywhere else on the page. And that's not necessarily true. For us, that happens because, once again, because the things we're writing are very simple, but JavaScript and most programming languages in general are actually very protective. They're very strict about which functions, in most cases, which functions can access which variables. Like, not all functions have access to every single element or every single variable on the page. So in this case, obviously, super simple, right? We have a variable, we define it on line 4, and we run it on line 5. In this case, everything's good, right? Like, we define a variable, we use it right away. It's pretty straightforward. Similarly, if we move on to something called the global scope, well, actually, let me go back to this. So lexic scope. Basically, a variable scope is defined based on where the variable was created, not where it is used. And so a variable scope is defined when it's created, and who and whether or not another function or another piece of code can use it is dependent upon where that variable was created. So the easiest idea of scope is something called the global scope. Global scope, as the name kind of implies, means everyone has access to this particular variable. Global variables, or I call them global variables, basically variables on the global scope. They're very flexible, but they're also somewhat of an anti-pattern in programming, in the sense that you actually want to avoid using variables as much as possible, or using global variables as much as possible. So why? I guess I just kind of shout them out. But like, why do you think computer languages are so strict about scope? And really, conceptually, why are they so strict about which functions have access to which variables?
No confusion, less confusion.
Less confusion.
Yeah, I was gonna say the computer would like freak out maybe.
Okay. Andrew.
Well, I think also for like a really big program, you run out of names for variables after a while. Like you could use I for index a lot, but if it wasn't like
Sure.
that, you couldn't.
Yeah. So I think that kind of feeds into the confusion, right? That you kind of have naming collisions. Anything else? Lex?
Maybe for something really complex, you might use more memory to.
Not exactly. And it's just because depending, like, if you need 20 variables, it doesn't matter what scope they're in. It's still 20 variables worth. I mean, there might be some nuances there, but actually the main reason why scope is super important is for security. And it's because if you so the way that the basic programming paradigm, and I mentioned this to Lucas very briefly just during the break, is that you actually, like, computers once again are really good at doing very simple, very precise tasks many, many times at a scale that humans can't obviously do them at. And really, one of the main patterns in programming is, hey, I'm going to give this particular function, I'm going to give this particular piece of code everything it needs to do this one thing, and then it was do it, give it back to me, and then I'll decide what to do with it next, right? Um, I mean, maybe this is not the best analogy, but let's say you work at a bank, right? Um, your manager or your boss is going to give you all the information, all the tools you need to do your job. He's not going to give you maybe the codes to the vault. He's not going to give you all the bank's super proprietary financial information, right? Same way when you work in government, right? You get security clearance up to the level that you need to do your job. They don't give you say, hey, here's access to everything, right? And so in a lot of programming environments, security is one of the main reasons why we use scope, right? This function should only need to know these things to do its job. So that's the only thing that I'm gonna give it access to, right? Nothing more, nothing less. And so when we talk about scope, if you have something that is accessible to everyone on the page, by definition, it's also the least secure thing on the page because anyone can have access to it, and not just have access to look up to see what the value is, but also potentially access to change it, right? So if I have like a sandwich, right, and I leave it in this room and put it on a table over there, and I leave for like a week and I come back, even if the sandwich is still there, I don't know if anyone did anything to that sandwich, right? And once again, really poor analogy for a global variable, but it's kind of that idea that it's like I have this global variable, and I don't know, like anyone else can read it, anyone else can change it, and the next time I use it, I have no idea who's done what to it, right? So it could be the value that I expect it to be. It could be something completely different because someone else used it for another purpose, right? And they were using it improperly. And so that's why global variable is a bit of an anti-pattern, that you almost never want to have a global variable. Every variable should have a confines or a scope in which that variable is useful. Make sense? Cool. Okay, so in this case, we have, once again, a variable we call global. We console log it out. Super easy. That makes sense. And then here, we have this other function called fun function, and it also console logs out this global variable. Now the question becomes, when we run fun function on line 14 there, this is gonna, I'll just kind of give away the answer here. On line 8, we're gonna console log out outer plus year, right? What's inside this fun function? What's this gonna console log out?
Inner year.
Okay, we have one vote for inner year. Francisco, or are you supporting that vote? Yeah. Any other guesses? Yeah, well done.
Oh. How'd you do that? Maybe soon I'm just gonna do something crazy.
That's like 3 sides from now. Cool. Okay, another spacing issue. There should be a space here. Anywho, but yeah. So the idea is that the idea is that, and I mean, if you read lines 4 through 5, kind of gives away the answer a little bit. But the idea is that essentially this variable we created on line 6, this is kind of almost like a global variable because this is like at the highest level of the page, which means anything else on this page has access to that variable. Yep. Okay. So here is something that we talked about. I think someone yesterday asked a question about hoisting. They were sitting there yesterday. Who was it? Someone asked about hoisting yesterday, and they were sitting there, but they changed seats. Oh, the okay, yeah. So, this is kind of a bit of a detour, really, but I'll just say that in JavaScript, well, I mean, if you look at this example here, so here's where, to Nancy's point, crazy things are going to happen, right? Line 5, we console log something called wait for it, and then we create the variable on line 7, and then on line 9 we print it out again. And when we look at the output, the first time it says is undefined, corresponding to line 5. Then line 7 happens, and then on line 9 we actually console log out again, and it actually is the string that we've created on line 7. Okay, so looking at this, I think if we block out line 5, line 7 and 9 make perfect sense to us. But on line 5 there, it says undefined. What does that mean? And so this speaks to something called hoisting in JavaScript, which is that when JavaScript reads a particular page of code, it actually doesn't necessarily read it in the way that you think it does, which is it starts from the top and works its way down left to right. What it'll actually do is it'll actually scan the entire page first and just make a note of which variables are going to be on this page. It doesn't assign the value to the variable just yet. Instead, what it says is, hey, on line 5, so the way the computer will read this particular block of code from lines 5 through 9 is it would go through and say, okay, on line 7, we have this variable called wait for it. I don't know what it is. I don't care just yet. All I know is this variable called wait for it exists. Okay? That's what the computer recognizes on the first pass through. It just makes a list of all the variables that it sees on the page. Online, and then it goes through the code a second time. And the second time is when it does kind of what we expect to do, which is it actually starts executing the code. Now, undefined is a fairly special property in JavaScript. And what undefined means is, hey, this thing has been created. We just haven't given it a value yet, right? And so the way the computer is going to read these 3 lines of code is it's going to go through it the first time. It's going to say, hey, variable wait for it exists. Great. Nothing else being created. All right, that's my first pass through. Second pass through, console log out, wait for it. Wait for it. It won't throw a reference error on line 5 because it knows this variable exists, but it doesn't know what value it's going to be just yet, which is why it prints out undefined. On line 7, it actually gives it this value called here I am to this variable, and so on line 9, when we print it out again, it actually prints out the value that we want. And so when we talk about hoisting, it's this idea that all of these variable names, they're hoisted to the top of the page. It's almost like you define them out at the very beginning so that you can use them somewhere else on the page. But obviously, and to a large extent, order still matters, right? Because if I was to print out line 5 versus line 9, there's clearly a considerable difference as to what the value of that particular variable is. Nancy?
How can you tell if the variable is global? Just
Yeah, pretty much. There's nothing that dictates a global variable. Oh, actually, it's a good detour. There is a way to create a global variable, and it's to create it without using let, var, or const. So earlier when I was telling you guys in the for loop, I was like, hey, you always want to let here, right? When you create, let I equals 0, I is less than whatever it is. If you don't use let, that I becomes a global variable, which is, once again, an anti-pattern. You don't want that, right? You don't want other functions to touch the I variable because that could mess up your for loop, right? So, or I guess more appropriately, your use of I variable could be messing up someone else's use of potentially the I variable as well on a global scope. So that's one surefire way to create variable. That's why if you in JavaScript, you just do like global, like David's new variable equals 6 without using let or var or const, it will run. It will still execute. Although I think in REPL, it will actually throw a warning at you saying, hey, there's no scope here. Are you sure you want to do this? Because once again, it's just a really bad pattern to do. It works, but it's a bad pattern to do. Yeah, Francisco?
So I thought this on console log, and like it still gives me a reference there even with the let wait for it like defined on like line 2. Is that just because the console log?
Are you running it in REPL?
Oh no, no REPL.
Where are you running it? In Chrome?
Yeah.
Well, so in Chrome, what actually happens is in Chrome, I'm assuming what you're doing is you're writing a line of code, pressing enter. Writing a line of code, pressing enter.
I put those 3 at once.
And it gives you a reference error?
Yeah.
I'll take a look at that. That shouldn't happen. Because if you execute these in sequence independently, that's going to throw a reference error. If these 3 are being kind of ingested as part of one code block, it shouldn't happen. So we're going to take a look at the break. But yeah, cool. So that's why if I try to use a variable before it's quote-unquote assigned, it won't throw a reference error. It will just say no value given yet, but it exists, right? And so one of the things that, you, as a developer, you eventually start picking up on is like, hey, undefined, not the worst thing in the world, because it at least tells me that my variable exists somewhere, that it's been created somewhere on this page. I just don't know what it is yet. Okay. Any questions? Yeah, right?
Yeah. So you said how it doesn't read top to bottom, left to right, it scans the whole page for variables. I'm a little confused why if it does that, how come row 5 doesn't pick up what the variable is?
Because it's not been assigned a value.
It's not been assigned a value.
Right. So think of it this way. On the first pass through, it only looks at things on the left hand side of the equal sign.
Okay.
Right. The first pass through doesn't run any code. It doesn't do any calculations. It just merely notes what variables are being created. And one of the things we also talk about when we talk about functions is this idea that like, hey, functions are also variables, right? So it also picks up functions in a similar way. But we'll talk more about that when we talk about functions. So just kind of hold that thought for now. Okay, so now that we're talking about functions, let's talk. So global scope, hopefully you know what it is. Hopefully you also know not to use it. In my mind, global scope code is probably just like bad code. Like you really need to think about kind of what you're trying to get your code to do. Functional scope, on the other hand, is once again, is now we're kind of entering this world in which, hey, the curly braces that you were using yesterday, those very clearly define what the scope is. So if I have this function here called happy function, in the function we create a variable called message. We console log out the message. This looks great. If I run lines 10 and 11, I guess what does line 10 do and what does line 11 do? What does line 10 do? It runs a function, correct. What does it print out?
I'm so happy.
Okay, yeah. So line 10 we have to print out I am so happy. And what about line 11? Undefined. Why undefined?
Well, message isn't defined outside of the function.
Okay, so that would give us undefined.
I would think, yeah.
Okay. Any other guesses? Okay. So why reference error?
Because that variable only exists inside that function, so
If it makes a note of every variable in the function, like
Okay.
in the code,
Mhm.
it would be undefined. So it's not being defined anywhere outside of that function.
Okay. Any other guesses besides undefined and reference error?
I'm just gonna say it'll print it just to
It will print out I'm so happy,
Yeah.
like it normally does. Okay, cool. All right, so we have 3 camps here: I am so happy camp, undefined camp, and reference error camp. How many people think I am so happy? 2. All right, cool. How many people think undefined? 5. 5. Yeah, 5. Okay. How many people think reference error? 5, 6, 6. Okay, 5, 6 on the fence. All right, cool. So we have 2, 5, and 6. Okay. Crazy stuff's gonna happen. Whoa. Okay, yeah. The correct answer is reference error. So this talks about 2 really fundamental concepts when we talk about scope, right? And that is this. Scope is one of those things where it's like it only works. The way I've previously explained this with another really terrible analogy is this idea that like so with scope. Scope means that you can see whatever's in your sandbox. You can see what's in the sandbox outside of you, and what's in the sandbox outside of that, etc., etc. But you can never see inside someone else's sandbox, right? You can never see inside someone else's scope. And so the poor analogy that I used to use was, it's like, like if I think about like money and family, right? Like I have access to my bank account. I may or may not have access to my parents' bank account, right? I may or may not have access to like my grandparents' bank account, but I don't have access to my siblings' bank account, right? Like at a certain level, like there's a very clear distinction between what's mine and what's someone else's. And so in this case here, on line 5, when we talk about happy functions, right? Line 10, hopefully that's just everyone understands, like we create something and we print it out. There's no ambiguity there. On line 11, when we print out message, what we're really saying is message is being created only within the scope of this happy function. If you're outside of happy function, you can't look inside my scope. If you can look inside my scope, then there's no security, right? Then everything becomes a global variable. There's no point in hiding variables inside my function scope, right? Happy function could very well say, I don't want anyone else to see what I have inside of this function. And so therefore, if you're outside of it, I'm a black box. You can't guess or know what's inside of me. The question that I think, or the point that Leo brought up was, hey, if a particular page goes through and makes a list of all the variables, like shouldn't we know it? It's like, well, yeah, it makes a list of all the variables that you have access to, right? It's not going to make a list of all the things you don't have access to, because by that definition, you would also know that they exist, right? Which kind of violates this fundamental principle of, hey, you only need to know the things that you should know. And so that's why when we print a message on line 11 here, as far as line 11 is concerned, the page says, hey, I have this function called happy function. That's it. That's the only thing on the page. So if you want to do something with that, like you are on line 10, feel free to. Go ahead. No problem. Message, I don't know what that is. It may or may not exist. Not my problem. It's definitely not something that you can have access to. Yeah, Leo?
But would it make sense to think about it kind of like this way, that on that first pass through, it makes a list of all the global variables?
It makes a list of all the global variables. It makes a list. Just think about it as it makes a list of all the variables that that particular scope has access to at that time, right? Because, and the reason why I make that distinction is because, let's say on line 9, I have a variable called, let David's new variable equal 6. If I'm inside happy function, I have access to that variable, right? Because it's outside of my function scope. Or rather, like I can look into my parent scope. So one of the things that, and the reason why I use a family and money analogy was because when you think about in JavaScript at least, a lot of like the relationships are thought of as a family. So for me at least, like if I'm happy function, I have access to my scope and I have access to my parent scope and my parent's parent scope, and I basically have access to every scope that I'm quote unquote a part of until I reach the global scope, right? What I don't have access to are my sibling scopes of scopes created kind of adjacent to me or even inside of me. Just like how I might have access to my parents' money. My parents don't really have access to my money. It's kind of it's a single directional relationship. Like I can only look on the scope outside of me, not other scopes inside of me. And Brian, do you have a question too?
Yes. So reference error does not tell you that that variable might exist in some block that you don't have access to.
Exactly. I mean, if it does, then it defeats the purpose of the security, right? Like you don't even know what's inside of that black box.
Okay.
Exactly. Okay, cool. So now we're gonna come across something, and I think I think Kojo and I think Lex and I think Nancy or Andrew brought up like this idea of like, okay, well, what if I have multiple variables to the same name? I have this collision, right, of things overlapping. What happens then? The short answer is the way the JavaScript is implemented is I will look in my scope first for a variable. If it doesn't exist, I will look in my next outer scope, see if it exists. And then I will look in the scope outside of that. So there's a very clear sequence of scopes I will look at. I will look in my scope from top down. I will look in my parent's scope top down. I will look in my grandparent's scope top down. And really, like the first match that I find, that's like the variable that I'm gonna use. So in this case, if I have a message out here called message, or if I have a variable out here called message, and inside my log a message function, I also have a variable called message. When I log it out on line 9, I'm gonna look in my own scope first. And if I see something called message, boom, like I use that. I don't care if anyone else has it. My version is the best version, right? Like on a priority queue, like I should be using this first. Back to the money analogy. If I need to pay bills, I should use my money first, right? And so in collisions, so therefore it's almost like, so you won't ever have a quote unquote collision in JavaScript because there's a clear precedence of which, if you have identically named variables, which one gets used first in which order. And it's always your own scope first, then the next one out, then the next one out, then the next one out. And a reference error basically happens when it says, hey, my scope doesn't exist, my parent's scope doesn't exist, parent's scope doesn't exist, all the way to global, it's not on global. Okay, great, I'm just going to assume that this variable does not exist. Hey, you were trying to use something that doesn't exist, here's an error, stop it, or just fix it. Cool. So here, when we do this function on line 12 there, when we do log a message, the message that's going to log out is going to be the local message because it's going to say, hey, I'm looking for a variable called message. Do I have one? I do. Great. Cool. I'm done. I don't care what other variables exist on someone else's scope, right? My scope is the most important one. Like my scope is the best, or at least my scope takes priority. In this case here, so this is like another example of the talk about earlier. Once again, on line 10 now, we're trying to log out message. Hey, does message exist on my scope? No. Does my parent scope have it? Yeah. Cool. Use that. Right? So now when we log this out, it will say think globally, because if this variable doesn't exist in my scope, let me look out to the next one. And then if that doesn't exist, the next one, until I get to global. And if it doesn't exist, then I stop. Yep. Okay. Parameters, same way. When I say parameters, what I'm talking about is this little thing right there. I think normally when we define parameters, we're kind of fairly casual about it. We're like, oh, we'll call it whatever, right? And then we use it in our function. But really, like what I always tell folks is, if whenever you have a parameter in your mind, almost imagine in this case between lines 5 and 6, there's an extra line of code that says let message equal whatever the value is, right? Because when you have a parameter, you are essentially just creating a variable to be used in that function. And so the scope of that variable exists within this function. This is why on line 6, when I log out message, it's going to say, hey, do I have a message variable in my scope? And the answer is yes, it's a parameter. I made it right here. And so what is this value? The value is act locally, right? I never check to see out here because I have a variable scoped locally already. So why not use that one first? Good. Yes. Everyone's pretty comfortable. Yeah.
Sorry, I lost. Act locally. Where's that output coming from? Oh, that's you putting that in the function.
Line 9. Yep. I'm passing it explicitly. Everyone good?
Almost, when you do that, it almost seems like you don't need the rest of the code, just right.
You don't need line 3 because line 3 is never gonna. Well, at least based on what we've written so far, line 3 will never get read, or it will never get we'll never need that value of message, because the only place where we use message is on line 6, and line 6 is always going to get it from line 5. So line 3 is in this case not relevant. Okay. All right. This one. It's going to require a little bit more of a kind of like step by step, but hopefully not super complicated. We very conveniently have this thing called global var for you. It's the name. Great naming. Clearly global variable. We have a function called outer, and inside this outer function, or inside this named outer function, we created something called outer var. It's a string called outer. And then inside of that, we create another function called inner, and in that we create a inner var. And so, really, like, if we think about code, one of the things when we talk about code as a group, we really should get in the habit of one, using line numbers, and then two is we should also talk about kind of like, okay, what's the order in which things are happening, right? So if I was to look at this page, on line 2 we create a variable. Cool. We don't do anything there, right? We just create a variable. That's fine. I don't really talk about that much for now. Line 4 through line 12, we create a function called outer. Okay, great. Nothing really happens. In my mind, the first line of code on this page that's actually relevant is actually line 14, because that's the first instance in which we're actually executing code. We're actually doing something, right? If I remove line 14 from this page and I run this page, nothing happens, right? I've defined a bunch of stuff that I never use. So really, like, I really don't need to look at it until I actually need to use it, right? So line 14, okay, I need to use something. I need to use this function called outer. So I would say, I start on line 14, I then jump to line 4, because I'm actually calling the function. Line 4 takes me to line 5, and then line 5 is, and then after line 4, line 5 gets created, line 7 gets created, but once again, like, if I pretend line 11 isn't here, this function doesn't really do anything, right? It creates a bunch of variables. It creates a function, it creates a variable, but we don't really execute anything. But on line 11, we actually execute the actual function inner. So then I would say I go from 14 to 4 to 11, and now to 7. And then in line 7, I now run through line 8, which I create a variable, whatever, doesn't really matter for now. Line 9, I actually need to do something now, which is I run this console log. And this console log is going to say, hey, print out 3 things: global var, outer var, inner var. Global var, do I have a global var in my inner function? The answer is no. Okay. Do my parents have it? This outer function? No. do my parents' parents have it, which is in this case also the global scope? And the answer is yeah. Okay, great. Let's use that value. Outer var, same thing. I don't have it, but my parents do. Let's use that. And then I have inner var. And so when I actually run all this code, I print out global, outer, inner in that order, right? So conceptually, we go from line 14 to line 4 to line 11 to line 7 to line 9, and then we finish the code. So that's kind of the order in which we run things, and it's pretty helpful to think about code in the sequence in which it's being run because ultimately that's kind of what really matters. And then this slide is just another similar example of this idea that we're going from line to line, code to code, and we're looking at different functions. We call outer, we pass a string called outer. See, this is really hard to talk about because we named everything like so similar that when I talk to you about it, it's hard to distinguish the difference between them. But essentially, we start on line 14. On line 4, we start running this function. On line 5, we're basically secretly creating this variable called collision and setting it equal to the string outer that we passed in. And then we do the same thing within, and then we go to line 11. We run inner. Line inner has its own function, has its own variable called collision. And so when we log out collision, it will look at its own function first. It will say, oh great, I have a variable called collision. It's called inner, or it's a string inner. Let's console log that out, and that's why that logs out inner. And in this case, same example as before, except we don't create our own version of the collision variable. So we don't have it inside the inner function. Let's just look in our parent function. Oh, we have it there. Great. Let's print that out. And so we print out this. It'll print out outer. And then lastly, we have, you can probably see a pattern here, right? We went from looking at our own scope to looking at our parent scope, and now we'll basically look at the global scope. So we'll print out global. Yep, and once again, this just kind of really belabors the point that that we look in our own scope first, then our parents' parents, etc. There's a clear kind of outward expanding order. Once again, feel free to look at these slides on your own. I feel like we kind of talked about them as a class, so conceptually, there's probably not much more to get out of these. Yep, cool. So same idea. Same idea. We're always going to go through our own local scope first. Wow, we're really hammering that point home. Okay, so that's function scope, right? We look at within the context of a function, and really when we use let or const, all we're saying is, hey, your scope is now confined to that function. Block scope. When else do we use curly braces besides in functions?
Objects.
Yes. Okay, but what else? Sorry. Objects is completely correct. When else do we use curly braces besides functions and objects? Yeah, all of our loops, right? If you consider if a loop, if else loop uses curly braces, while loops, for loops, some other ones too. So every time we create a curly brace, or every time we use a pair of curly braces, we're essentially creating a new scope. We're creating a new sandbox, a new environment. And so in the same way that functions have these, when you use let, in the same way that those functions create a variable in that scope, if I create a variable within a if, else loop, a while loop, or a for loop, yeah, those functions are going to be contained within that if loop, while loop, or for loop. And anyone else who tries to read it, they can't see inside of it. But within a loop, I can read my parents' variables, my parents' variables, my parents' parents' variables, etc., all the way up into the global scope. So same exact idea, except we replaced the idea of functions with while, for, ifs, elses, etc. Okay. All right. Cool. Yeah. So in this case, once again, inside here we print out Jenny from the block. Totally cool. No problem at all. Out here, I don't have access to this block variable, right? It's inside the scope of a child scope. So line 9 is going to give us a reference error, much like it did in the first example too. And then the only thing to know here, this is more of like a FYI, is you might be wondering, hey, I saw we use let a lot. Why not we use var? In ES5, we use var for everything, and var only has function scope. ES6 introduces let variable, which now says, hey, you now have function scope plus block scope. So just like a nuance there. Quite honestly, for I think for our workshops, there's actually not too much of a difference which one you use. I think if you want to start using let going forward, it's probably a best practice because it's just let gives you kind of more control or more sophistication over, or sorry, more control over where your variables can be used, and that level of being precise about like your code and how you're writing it and how you intend to be used is always better than being more ambiguous. Because once again, computers terrible at ambiguity. So I mean, this is just an example of like, hey, if I have a global variable and everyone else is changing the global variable, by the end of the day, I don't even know like what that variable is anymore. So just try not to use global variables. Yeah, so don't use global variables. Like, I think most environments will throw like a warning to you at the very least, if not an outright explicit like don't use global variables. So just be judicious in kind of how you think about that. And that's pretty much scopes. Cool. Any questions? Francisco? Yeah, totally. Okay, any last questions on scopes before we dive into the workshop?
Slide before this one.
Yeah.
Or a couple before this one, I can't recall which one it was. Was the point just not to have the same name, always true, but always true?
Oh no, the point of this slide was just to really quickly tell you that, hey, I have a global variable, so to speak, called always true, and someone else can change it to false. If I try to use it down here, I never see that.
Okay.
Like when I call always true on line 10, I have no idea who's changed it in the interim. So that's like the big danger of global scope. Is that you can use a variable that you know what it was originally, but you don't know who's changed it since.
Because in this case, it would be true, right? If you access it below.
Well, on line 10 it's false, right? Because on line 8 we call don't mind me. Don't mind me change. Oh wait, no, you're right. This is fine. Yeah, sorry. The previous example, sorry, in this example it's fine. The previous example. So this is bad because on line 8, don't mind me, we changed the global variable to false. So by line 10, we're going to jump to line 12 because if it's not true, it would be false. So we go to the else statement, which throws an error. On the other hand, what the point of this is saying, hey, if we now create a new variable inside this don't mind me function, it won't change the global. It will just create its own version of this always true variable, and the original global won't be changed.
Yeah.
Yep. Okay, cool. Any other questions? All right. Really? No questions at all? Sure. All right. We'll see how the workshops go.